In this lesson, we will continue to work with the modified Excel data from our previous lesson. Our goal is to bring that modified data back into Revit in an efficient way. To begin, we will need to open the Revit project file included in the datasets folder for this lesson. And we can do this by dragging it right onto the Revit home screen. This Revit file is the file we used previously that still contains the misspellings in a random number of room names. Once we have the model open, we can navigate to the Manage tab and open Dynamo. We'll go ahead and maximize Dynamo and click on New to start a new blank workspace. Since we will be working with data from Excel, we need to first place the node that interacts with Excel data. In order to find the nodes that interact with Excel, we need to navigate to Import/Export, Data, and in our case, we're importing from Excel now, so we can place the Import Excel node. With the Import Excel node placed, let's take a moment to observe the inputs. Our first input is titled File and has the description, File representing the Microsoft Excel spreadsheet. We can also notice that this type of data is of type file. So in order to fulfill this input, we need to open the Excel file in memory from the given path, which is a string or a series of text. Let's go ahead and fulfill this input now. In order to do that, let's search the library for a file path node. And we'll click on file path to place it on the canvas. And we'll place it to the left of the data.importExcel node. The file path node is unique because it has a push button UI that allows us to pick a file from disk. By clicking on the button, we can navigate to the Excel file that we previously created. And we can select the Excel file on disk. Now that we have the file path node complete, we can load this file into memory. In order to do this, we need to place another node. So in the library, let's search for a node called File from Path. We'll click on it in the library to place it on the canvas. And we'll clean up our node layout a little bit. Once we have the File from Path node placed, we'll notice that it turns yellow. This is because it's not quite fulfilled. It's requiring a path input, which is a string. You can observe this by hovering over the input. In order to fulfill this node, let's connect the output of the file path node into the input. And we'll notice that the node turns into the light gray color and it's no longer in an error state. If we hover over file from path, we'll see that it now has that file loaded and we can use this node's output to fulfill the file input of the import Excel node. Observing our next three inputs, we can see that we have sheet name, read as strings, and show Excel. Read as strings allows us to perform a conversion on all of the data from the Excel document to convert it to a string representation. By default, this has a value of false, and we can leave it as that for now. The show Excel input allows us to be able to show or hide the main Excel window on runtime. By default, this value is true, so it will show Excel opening to the end user. If we want to change this value, we can specify a different boolean, which is a true or false value, to change its option. In our case, let's double-click for a code block and type in false. Once you click outside of the code block, this output will be fulfilled with a boolean, which is a true or false value. We can plug this in to the show Excel input. With that input fulfilled, we can now look at our sheet name input. As you can see, this would be the name of the worksheet that contains the data that we want to access, and this is a string object, so this would be a text value. If you remember, in our last lesson where we exported the data to Excel from Revit, we had the opportunity to name our sheet. In order to review what the sheet was named, I will open the Excel file manually. As you can see on the bottom left corner of the screen where the tabs are for the sheet names, our sheet that we are interested in is titled Room Data with no spaces and a capital R and a capital D. In order to fulfill the sheet name input, we can go back to Dynamo to do this now. and I'll close Excel. Rather than searching for a string node, let's do a different option to fulfill the sheet name input. So we'll double click on our canvas for a code block, type in quote, capital R, room, capital D, data, end quote, click outside of the code block. We can use this as a string now. This allows us to specify a string which is text in a code block node. So as you can see, code blocks are very versatile and can be used to fulfill all sorts of data types. We can now connect this output into the sheet name input on our import Excel node. Once we have that node connected, you'll notice that Dynamo ran since we are on Run Automatic currently. This means that this node went ahead and did the action that it's aiming to do, which would be reading from Excel. We'll reposition our nodes to the left to clean them up a little bit. And then we can hover over our import Excel node to view its output now. Once we pin the node preview, we can see all of the data available to us. We'll notice that we have two sublists in this node's output. The first sublist would be our element IDs that we obtained. This list's index is 0, and it does contain those element IDs for our room elements. This data is important because it allows us to select the exact room that the data was originally obtained from. The second sublist contains the revised room names that we corrected in Excel previously. In order to separate these lists, we can use two sets of getItemAtIndex nodes. Let's go ahead and search the library for the getItemAtIndex node. Once we complete our search, we can click on the getItemAtIndex node to place two copies of it. So we'll click it twice. And we'll place these nodes to the right of our import Excel node. And we'll pan so that way we can focus on this side of the graph. For the first getItemAtIndex node, our index will be 0. To fulfill this input, we can double click for a code block and type 0. And we'll reposition it a little bit. While we're in the same process, we can use the same code block to specify our input for our other getItemAtIndex node. This value would be 1. So if you click after the semicolon on the code block, type 1, and click on the graph, you'll notice that we receive an additional output. This is another one of the strengths of code blocks, is we can use one code block to specify several outputs to be used. We can tie these in now. 0 would go into our first getItemAtIndex node, and 1 would go into our second getItemAtIndex node. And these values fulfill our index inputs of those nodes. With these inputs fulfilled, we can go ahead and connect our data into the list input of each node. We'll click on data, connect it to the first one's list, click on data, and connect it to the second one's list as well. And now we can collapse our preview for our import Excel node and observe the preview of the getItemAtIndex nodes. Now we have our element IDs separated as their own list and our room names separated as another list. So this data is now its own thing that we can use independent of one another. Paying attention to our element ID list getItemAtIndex node, we can go ahead and work on selecting our rooms with that element ID. If you remember, in the Revit UI, we're allowed to select elements by their element ID, and we can observe that now. In Revit, if you go to the Manage tab, Inquiry panel, there's an option to select by ID. In Dynamo, we have this option as well, and we need to access it in kind of a unique way. We'll re-maximize Dynamo. In order to access this ability in Dynamo, we need to utilize a code block in a really cool way. So what we can do is double click for a code block and type in some code directly into this code block. Within a code block, so far, we've only really used them for string entry, number entry, and booleans in this example currently. We can also use it to author design script code. Design script is a textual programming language that is underlying everything in Dynamo, so we can actually author this code directly in code blocks as well. Just about every node has a design script equivalent and will be able to be accessed in this manner. So in order to access the element selector method, we can type the following into this code block. We'll type Revit with a capital R dot element selector dot by element ID, open parenthesis, lowercase id, close parenthesis. And once we click outside of the code block, we'll notice that it has an input of ID and it's currently in an error state. The reason it is in an error state is because we haven't fulfilled that input quite yet. What we can do is we can connect our element IDs into that input to fulfill it. And we'll notice that the code block turned that light gray color and is now fulfilled. We can also hover and observe the code block's output. Once again, we can notice that this node is currently working because it's retrieved our Revit elements from the current Revit document. We know this because in the node's preview, there's a green element ID next to each of the elements. This means that it's an actual Revit element that we can now interact with. Additionally, this code inside of the code block allows us to access the Revit interactions, the element selector methods, and we're using the element ID selection specifically. Now that we have the element selected, we can change the room name based on our Excel data. In our library, let's navigate to the Revit category. Within the Revit category, we'll navigate to Elements, and then Element. Since a Revit room is an element, we can use most of these options on the rooms. In our case, we want to set the room name. So that would be a parameter in Revit, and we have the option to set a parameter by name. Let's place this node now. And we'll go ahead and reorganize our graph a little bit so that way we can see what's going on this back half. Observing the inputs of the set parameter by name node, we can see that it takes an element as the first input, a parameter name, which is a string or text, and the value, which currently says var, but that means that it can take a variety of things. So a Revit parameter could be anything from text to a number to a yes/no parameter, things like that. We can set most of those parameters with this node. In our case, let's take a look at what parameter we are wanting to set. I'll minimize Dynamo for now. If we zoom in, we can actually hover over a room and select its location lines to be able to select the room element. Within the room's parameters, we'll notice that the parameter we're observing is called name with a capital N. So back in Dynamo, we can specify the parameter with the same name. We'll re-maximize Dynamo. In order to set the parameter name, we can go ahead and use a code block once again. So we'll double click for a code block. We'll type in quote, capital N for name, end quote, click outside of the code block, and we can tie this output into the parameter name input. Once again, using a string value like this inside of a code block is a really fast way of being able to define these variables. Our elements will be the elements that we obtained with our code block and the element selector method that we used above. So we can connect its output into the element input. And in order to observe these changes live, we can go ahead and tile Dynamo next to Revit. And I'll go ahead and collapse my library so that way I can see more of the Dynamo graph. And we'll pan over to the set parameter by name node. As you can see, we have cafeteria currently misspelled, electrical over to the right, and several others. If we go ahead and tie the output of our getItemAtIndex node, which has the corrected spellings of the room names, into the value input of the set parameter by name node, it will run automatically, and you'll see the values change on the fly. This is because we're currently on run automatically, which we can see on the bottom left-hand corner. As you can see, we've revised the room names based on that Excel data that we extracted and revised previously. This example shows the power behind connecting Dynamo to an external program and how to efficiently access this data throughout this whole process.